Hello everyone. So we'll be studying AWS in these sessions. The basics of AWS, what is AWS, Amazon Web Services, what is cloud computing, what was the need of AWS, all this in details. So let's quickly move forward to creating an AWS account. So what we need to do is we just need to go to AWS sign up. We need to click on this. Create an AWS account. Need to get the user email which you will be using. So I'll give mine. Basically verify that this user ID exists and it is not in use with any other AWS account. The name you want, let's say coach, tutor or something like that. So let's verify the email address. A verification code will be sent. Let's check that. Okay, 693080. Let's verify. Okay, now it's been successfully verified. Now let's see what it asks. It is asking for sign-in access to AWS. We need to give a password. We have to give a password maintaining all these rules. Confirm password. So how do you plan personal for your own projects? Okay, full name. Give your full name like coach. Whatever your full name you want to give. So I'm from India, so I will give the India extension. So 1 second, I'll just share my screen back. Okay. Now, how do you plan to use? Okay, let's say, right, and then address whatever you want to give. XYZ, maybe whatever you want to give, whatever your address is. Then you need to give your postal code. I've read and agreed. Then you need to do the sign up for AWS. You need to give the debit card number. So basically, it's for the verification. It will only charge you ₹2, mostly for India India account creation. It will be refunded also to your account. It's basically to verify your identity. So, as you see over here, it's written, we will not charge you for usage below AWS free tier limits. I'll come to that. What is AWS free tier limits? So once you do that, just verify and continue. You need to give that. So once you give your billing address and everything, it will just show you that your account is created and you can successfully use that, right? So this is how you can create your AWS account. Let's move on to the next lecture and see what AWS actually is. Let's see. Okay, so let's proceed and see how our AWS account looks like after it has been created. So the account is created. So before signing up, the signing up completes, you have to select the support plan. So I'll select the basic support free, which will be okay for all the AWS services. It depends from organization to organization for developer support and business support. So we'll go into that later how different it is. But so that you don't have to spend much amount or any amount, basically you can do it for free. We'll create the basic support and we'll complete the sign up. So we have signed up. Let's go to the AWS Management Console and let's see how it looks like. Okay. Let's go to the AWS Console. Okay, let's give our email ID from which we logged in. We'll come to what IAM user is. Right now, the root user is the same as what with which we created the account. Okay, and the password. So this is our AWS Management Console. Let's see some of the services. Explore one of these commonly visited services. Let's go to IAM because that's the one which we will be studying in the beginning for IAM roles. So this is how the console, the UI looks like basically. We'll come into all of this. You can see all of the services over here like this. Whichever part it is from, if it is analytics, let's see what we have, this application integration, let's see what we have. So this is how you can access your console, right? And if you want to sign out, you can directly sign out from that. So our account has been created successfully. We'll learn about cloud computing in the next lecture. Okay, so let's talk about cloud computing, what cloud computing is. So why you need cloud computing? In AWS, you always need to understand, in AWS or any other cloud, you always need to understand what is cloud computing, right? So before that, in the AWS basic CCP program, in the CCP certification, you need the ideas of cloud computing because there are some questions which comes from cloud computing as well. So let's take an idea about how websites work, right? So let's say here I have a client machine, okay, and here I have the network, okay, and here is the server which is kept, the server room or the servers where it is kept. So what happens? Clients have some IP address. I name this is C for client. This is network, and this will be server. So clients have some IP address. Okay. Now what happens is client connects with the network with that IP address, and network connects with the servers with the same IP address. Now client have the IP address, a different IP address, let's say A, and the network, the server have different IP address, let's say B. Now what happens between the client and the server? So when you are sending a post mail, you suppose you write a letter, you uh, post it in a mailbox to the given address, right? Let's say you want to send a letter to your friend. So you write the letter, the destination, and the post office people, they take the letter, they post it to, they deliver it to the required destination. This is how it works. Same with this structure as well. It's the same thing with this structure as well. So the clients, what they do, they have the IP addresses. They send it over to the network, which is like a shared network stuff. And the servers are also connected from the network. They receive it, the network, they deliver it to the servers. Henceforward, there is a connection which is enabled between the client and the server as well, right? Okay. So this is the basic concept behind how clients and servers work. Clients, as in you can say it is a computer. Like you have a Wi-Fi at your home, and your computer has a IP address. It connects with the Wi-Fi, and the Wi-Fi connects to the Wi-Fi servers, from where you get the connection. Now, what is a server composed of? Let's see that. So a server is server composition. So main things is, number one is the compute. Compute as in the CPU. We always have heard that there is a CPU in a computer, right? So what is a CPU? It is the compute processing unit. What it does is it helps in computation or basically calculations of your requirement data. Then we have the memory, because when we are dealing with data or any mostly data or any other stuff, we have to store it somewhere. So we have to store it in a memory. We have to keep a memory. So that is the RAM, random access memory. Then we have the storage. How the data is stored. The data is stored in terms of like this, in bytes, like binary 101, 011, 111, like this. These are each of the numbers, these represent a byte of data. Now, where will be the data stored? The data will be stored in a database. We have heard about this, that there's a database where the data is stored. So what does database do? It stores the data in a structured manner, right? Like it is in on-prem, like Oracle or MySQL Server or MS SQL, anything. It stores the data in a structured manner. Now there are networks. What are networks? Networks are like routers. When we talk about Wi-Fi, we have routers. We have DNS server. We'll talk more about what DNS servers are. Then we have switch. So these are the basics of a server composition. A server is composed of these basic things. Okay. Now let's move on to the next part. Let's talk about the IT terminology. What each of this means. So network. What are networks? Networks are basically the cables or the routers or the servers that are connected with each other. Then we have, okay, now I'll just draw a diagram. This is our computer. Okay. This is the router. Let's name it as R. This is the switch. Let's name it as S. Then this switch, this is connected to three other computers like this. Okay, so what happens? This computer sends signal to this router. This router sends signal to the switch, and this switch in terms connects to three other computers, basically multiple other computers. Now what happens? Let's understand the flow of it. So the network, these cables, routers, they are connected to each other. Okay. Now this router, what is this router? This router is basically, it's a networking, it's a networking device that forwards data packets. What are data packets? Packets of data, bunches of data. Whatever data it needs to forward, let's say a letter, you have something written in it. Similarly, it forwards data packets between the computer and the networks. So router basically plays an intermediate role in forwarding data packets from the computer and the networks. Now, what does this switch do? Switch basically, switch, this switch basically what it does is, it just takes that packet, data packet, and sends to the connected uh, computers. Let's say I have a data packet like this coming from the router, packets of data. Okay, this packets of data, this switch takes in, absorbs it, accepts it, and sends it to these servers or clients on your network. Now let's see. This is your Wi-Fi server room. from where you have taken the connection. So what router does, it forwards these data packets from the Wi-Fi server room to the switch. Switch takes it and distributes it to various connections of the client, whoever has taken the Wi-Fi connection. To be very precise about this. Okay. Now, how to build an infrastructure? One second. How to build an infrastructure? Let's say I'm working from my home. So I have my home. I'll name this as H. And this is my office. I will name this as O. So of course, if I'm working from home, I need to have connection built between my home and my office. So how do I get that? How will I build this infrastructure? Whenever we started working from home also, we got all the accesses and the connections from office laptop, right? From the office, the client requirements. So in that case, how to build this connection? What we do is, there's a data center. What is the data center? It's basically a collection of hardwares, servers. It's a separate room where all the hardware, softwares, the servers, everything is kept. From there, you build your on-premise applications, like you take the license from Oracle. It's an on-premise application. So all of that is done with the help of traditional data center, what we call mainly as on-prem, what we call mainly as on-prem, on-premises. Now, what is the problem with the traditional data approach? Let's say, so basically, the problems with the traditional data approach is that you are maintaining everything by your own. So you have to pay rent for the data center which you are running, which comprises of all the hardwares, which comprises of all the servers and everything. You have to pay rent for maintaining that. You have to pay maintenance. So then also you have to pay for power supply to have it run on its without any problem. You have to pay for the power supply. You have to pay for the cooling, because these are all devices. These are all machines. They can raise the temperatures, and also for the maintenance to see that everything is working fine, because everything is dependent on the data center where everything is stored. It's a very much important. It's crucial. Now let's say about hardwares. In your computers also you face problems with your hardwares. Now when you're when you are maintaining such a big data center where so many hardwares are there, you will see in movies also there is a room full of hardwares, like full of machines where things are maintained. So in that case, there will be adding and replacing of the hardwares as well, right? So that becomes a headache to maintain that. Then scaling is limited. What does it mean by scaling is limited? Scaling basically is, scaling means increasing the number of computers, increasing the number of destination computers. So in that case, when you're maintaining a physical data center, you have to always think about when you increase your number of resources. So that in that case, it happens that you cannot go forward or further than a particular limit. Also, there is a needed a 24/7 support team to maintain it, to keep an eye on it, so that if anything goes down, they can fix it as soon as possible. Now, there can be natural disasters like earthquakes. How to deal with disasters? There can be natural disasters like earthquakes, there can be power shutdown, there can be fire, there can be a lot of things. So how do you maintain your constant connection between your data center and your client computer? How do you do that? It becomes a very extensive process, right? There comes cloud computing. Okay, there comes cloud computing. We'll discuss on how these problems can be solved with cloud computing in the next lecture. All right, so let's move on to the next part, that is, which we were talking about, that what is cloud computing and how it is coming as a rescue to us. So cloud computing is basically a on-demand delivery of this compute power, database, storage, applications, and other IT resources. Okay. So how do you do it? It's basically, you can say it's a difference between Uber and your own car. So when you have your own car, you have to pay for the maintenance, you have to pay for insurance, you have to pay for premium, you have to pay for a lot of things. So it's your problem, and it's basically an on-premise system. It's all your headache. But when you go for Uber, you just rent, you just give the money as you go, the number of kilometers you go or the number of hours you go, you pay as per that. So you don't have to pay for the maintenance of the car or anything. So same with cloud. So the problems we face in the on-premise system, the traditional on-premise system, can be resolved with cloud. So pay rent for the data center will not be there. Power supply, cooling, maintenance not be there, because you're just paying the rent on the cloud and using the different databases or the softwares or the networks or applications cloud provides. And you go for as you pay as you go price. Whatever you follow the services you take, you pay for that, right? So exactly the size of computing you need, the size of memory you need, you can just opt for that and you pay as you go. So the most important part is that you can access any of the services almost instantly. Okay, almost instantly. And it's a simple way to access servers, storage, databases, and a set of application services as well. So, what are the pros of cloud computing? Number one, we can say pay as you go pricing. Number two, instant access, right? Number three, rent it, so cost reduction. Number four, as many resources, as many resources as per needs you can take. So these are the pros of cloud computing. So now tell me, which one will you go for? Will you go for traditional data center? Will you go for traditional on-premise, or will you go for cloud? So this is where cloud came. It's an exact replica of on-premise, on the traditional on-premise, but it has a lot of pros for which most of the companies are opting to cloud. Now there are three clouds. There are three types of cloud. There is AWS, Amazon Web Services, which we will be talking about. There is Azure, and there is GCP, which is Google Cloud Platform. So let's talk about the AWS. Amazon Web Services, what it does is it basically owns and maintains the network connected hardware. So whatever we're talking about in the on-premise, Amazon Web Services does the same. So whatever is required for the application services, while you take it, while you rent it, you can use it just via web application. And what's the web application? The console. You will see it has all the softwares you need when you are doing on-premise also. It has all the applications you need. It is the servers you need. Everything is on cloud. This is where cloud computing came and rescued us. So now after cloud, how can we see our picture? So this is our office. Okay, this is our office, and this is our cloud. Sorry for a bad cloud. And everything is stored inside of that. So all the servers, the data center, everything is stored inside the cloud. So what you can do is just connect like this. You pay for your services, you get connected. So this is how cloud works, and this is how cloud has come. Now let's take some examples. We have always been using cloud services. AWS, Azure, GCP is not the first thing. So some of the cloud services we have been using, Gmail, right? Gmail, we always use Gmail. So Gmail, we have used Dropbox. It's a cloud. We have used Netflix. It's also a cloud where the owners of the movies, they drop their movies so we can see. Also, Netflix is built on AWS, and it's a video on demand. Whatever video you want to see, you just see that. Okay. Now We'll talk about the different modes of cloud in the next lecture. Thank you. So in this lecture, we will talk about the different deployment models of the cloud. What are the types of cloud we have? So there are basically three types. One is private cloud. If you go by the name, what is private cloud? Only used by a single organization, not exposed to the public. It's inside of the organization. Number two, we have the complete control of the cloud. Since it's not public, we don't need to rely. It's only us inside the organization. Then we have security for sensitive applications or data. To make it secure for the leakage of data, you can use that, and then meet specific business needs. These are the properties of private cloud. What's an example? We'll see rack space. It's inside the organization, and these are the properties. Now coming to public cloud. Since it's public, we understand that it's not used by a single organization. So it's basically cloud resources owned and operated by a third-party cloud service provider, like AWS, like GCP, right? So cloud resources operated by third-party provider. Okay. Now, what are the examples? It can be AWS, can be GCP. Okay. Okay. Now coming to hybrid cloud. So basically, we understand it's a mixture of public plus private. Okay. Now what happens? What it exactly does? Keeps some services on-premise, some on the cloud. Now, what happens for keeping it on-premise? You can have control over sensitive data or applications which you don't want to expose to the cloud. Because there is a problem, there might be a problem of leakage of, risk of leakage of the data or the information basically. Also, you have for the hybrid cloud, you have the cost control. You have the effectiveness of public cloud. So benefits of public cloud. So these are the three models of deployment models of the cloud. There is private, there is public, and there is hybrid cloud. Now let's move on to the next lecture. So now comes the characteristics of cloud computing. And what are the characteristics of cloud computing? Number one is it's a self-service. You don't have to maintain anything, right? It's self-service. So basically, the users, they can provision the resources, whatever they want. If they want a database, they go for it. If they want servers, they can go for it. So without human interaction, right? You just take a subscription, like you created an account, just take a subscription of that from the service provider and you are good to go. So it's self-service, it's beneficial for the user. Now, broad network access. What does that mean? Resources available over the network. It can be accessed by diverse client platforms. Whatever resources you want to opt for, you can go for that. It is diverse. Now, you can have multi-tenancy. So multiple tenancy, what do we mean by that? Multiple customers can share the same infrastructure and applications with security and privacy. Multiple customers are serviced from the same physical resources. So there is no limitation that only one customer or one user. So let's move on to the next part, which is the advantages of cloud computing. Just give me a second. So advantages of cloud computing. So the number one advantage, as we have already discussed, is the pay on demand, right? So pay on demand. Number two is the reduced cost of ownership and also the operational expense. Okay. Now, these two things, this comes under trade capital expense. So you can see like capex and opex, capital expense and operational expense. Now, number two, benefit from massive economies of scale. What do we mean by that? That prices are reduced in AWS is more efficient because it is large scale, right? We already discussed about scalability. So since it is large scale, there is a massive benefit of that because the prices are reduced. Now, number three, we don't need to focus on the guessing capacity, then how much we have to get it or what is the amount we need. It's pay as you go. So since it's measured, you pay as you go, you pay as per your services. So no guessing capacity. Now number four, increased speed and saving money from maintenance. As we already talked, you don't need to maintain hardwares or other applications as on the on-premise. Also, you can go global in seconds or minutes. What do I mean by this? Since you have the access to the global infrastructure of AWS, like all of the regions, we'll talk about what AWS regions are. Since you have access to that, we can just go live. We can go global in seconds or minutes. These are the advantages of cloud computing. Now moving on to the next one. What were the problems solved? Number one, flexibility. We can change the resources type when needed. Number two, cost effectiveness. Of course, cost is reduced. Scalability. You can use and upscale your resources as and when needed. Then elasticity. What is meaning by elasticity? We will be able to scale out or drop it when needed. As I said, if you want resources, you add them. You don't want, you drop them. Number five, high availability. Since it's all alive, it's on the cloud, you will be able to build across different data centers in different regions. It's not that only one data center is available as it was on the on-premise. Now, agility. What is the meaning of agility? You can rapidly develop or test and launch your software applications, right? So you have more free access to it. So these are the problem solved in cloud. Now tell me, cloud or on-prem? So the answer is cloud, mostly because it solves a lot of our problems as stated above, and that's why we are mainly shifting to cloud. So in the next lecture, we'll talk about the types of cloud computing we have. All right. So now we'll start with the types of cloud computing. So there are basically three types of cloud computing, the basic ones. There are more as well. We'll come to that in the later chapters. So the first one is IaaS. What is the full form? Infrastructure as a service. So what does it do? It basically provides the building blocks for cloud. It also provides networking, computers, data storage space, this kind of facilities. Highest level of flexibility it has, and also it is easily traditional, easily parallel with the traditional on-premises infrastructure. Okay, so let's write down the points. Provide building blocks. Number two, networking. So whenever you see all those networking, servers, applications, all these are infrastructure as a service. Computers, data, storage, everything. Okay. Number three is flexibility. It has the highest level. Okay. Number four, it's easy, parallel with traditional on-prem IT. This is IaaS. We'll come to examples of that as well. Now the next one is PaaS. What is the full form for that? Platform as a service. Okay. So what does it do? Number one, it removes the need for your company or organization to manage the infrastructure. Okay. Number two, it focuses on the dev, development, and management of the application. So the basic point is it removes the need for the company to manage the infrastructure. It's not the company's headache to manage the infrastructure. Second of all, it focuses on the development and manages of management of the application. Again, it's not the company's headache to do that. PaaS, platform as a service, will provide that. Number three is SaaS. What does it mean? Software as a service. Basically, what it does, it's a complete product that is run by the service provider. Okay, so all the software related things that will be managed and run by the service provider, so AWS in this case. So this is the type of cloud computing. We have more as well, we'll come to that later. So basically, if we see, I'll share a diagram later. So in on-premise, what are the things we had to focus on? Number one, applications, data, runtime, OS, virtualization, servers, storage, networking. Everything was taken care by the on-premises. This is divided in cloud. So infrastructure as a service, it takes the IaaS, it takes applications, data, runtime, OS. Okay. Platform as a service, it takes virtualization, servers, storage, networking. So these are divided among the three types of cloud computing, among the three services which AWS has. Okay, now let's take examples. So IaaS. What is the example? So if you see, since it deals with networking, computers, all that, so we can say EC2. It's a very important service. It's a very, very important service in AWS. We'll come to that when we learn EC2. Also, all right, so let's come to the pricing part, pricing of the cloud. So AWS has mainly three fundamental pricing. What are they? So as I said that we have the pay as you go, right? This is the pay as you go model. So what are they? Number one is compute. So however time you compute from for, you get that pricing. Number two, it's storage. So whatever storage you use for your application or for your requirement, you pay as that. The number three is data transfer out of the cloud. What does it mean? That whatever data you are transferring out of the cloud, that you pay as per that. Data transfer in the cloud is free. You suppose upload something in the cloud, that's free. But whenever it goes out of the cloud, that's not free. That day you have a pay as you go pricing. Okay. Now, definitely this solves the expensive issue of the on-premise, right? For on-premise, you had to manage everything. But here, since you have pay as you go, you just pay for these three requirements. Okay, this is about the pricing part. Now we will talk about AWS cloud history and what are the regions, what are the basics of AWS as we talk about. So we'll start that in the next lecture. Thank you guys. We'll start talking about mainly AWS in the next lecture. Thank you. Okay, so now let's talk about the AWS use cases. In what areas these AWS services are used. So number one, it helps us build scalable applications, right? So that means it can be used in big data analytics. So it can be used for roles as a data engineer. Number two, it can be used in gaming. Number three, it can be used in website hosting. It can be used in mobile and social media apps. We had already discussed about Netflix, right? So it can be also used for entertainment, you can say. So these are the areas where AWS cloud can be used. Now what we will talk about is the AWS Global Infrastructure. So the basic points are, first we have AWS regions. We'll discuss among them about them in details. Number two, we have AWS availability zones. Then number three, we have AWS data centers. Data centers, you might be aware of the term. Okay, so now we'll talk about AWS CloudWatch. While learning AST, we had come across this term CloudWatch. So what is CloudWatch? CloudWatch is basically a service. It's an AWS service which provides metrics for every services in AWS. So what does that mean? Metrics is basically it's a variable to monitor, let's say CPU utilization, or networking, all those um, parameters CloudWatch monitors, right? Also, metrics have timestamps, so it's easier to understand the time at which, let's say, a job failed or a CPU utilization increased, all that stuff. Also, we can create CloudWatch dashboards of metrics. Now, okay, what we'll do is I'll just go to the CloudWatch service. So if we go to this dashboards, we'll see that we have an option of create dashboard. So let's see test. So what type we want to add? Let's say we want to compare metrics over time. Okay. So which data source? Let's say from logs. Let's say we run an EC2 job and we have the logs over there, or AWS Blue job, we have the CloudWatch logs over there. So whenever you're, whatever Blue job we have, we'll see that in CloudWatch, the logs are coming, and you can create a dashboard on top of those AWS Glue logs. Okay, so it's basically it's very important for the data analysts. Okay, so we need to select a log group. Let's say okay, jobs. We had run the AWS jobs, right? So let's do that. Let's see. Logs. Okay. Let's do something else. Let's say jobs. Okay. Crawlers. Okay, for this timestamp, we don't have any visualization. So if it is present over here, as per the logs, if suppose you run a glue job and it fails and whatever it comes, the logs will come over here and you will be able to see the visualization over here. Okay. This is the metrics, how you can manage your logs in CloudWatch. Now, let's talk about the important metrics. So number one is EC2 instances. So for example, CPU utilization. Then we have the status checks, network. So what we can do is we can have a default metrics every 5 minutes. Okay. And then we have EBS. Number two, we'll talk about EBS. We have EBS volume. Okay, then we have S3. We already talked about S3 buckets. So S3 buckets, what are the metrics to follow? So bucket size, number of bytes, and number of objects, like number of files inside the bucket, right? Then we have billing. So in billing, we have total estimated charge. In this, there is a constraint, it's only in US East 1. Then we have service limits. That is how much you have been using the service API. The number 6, you can have custom metrics. What does that mean? You can push or create your own metrics. Okay, so these are the important metrics in terms of CloudWatch we have. Now we'll talk about CloudWatch alarms. So alarms are, we know that it's used to wake us up. So it's basically used to trigger notifications for any metric. So what do alarms do? We already talked about alarms in auto scaling. So in auto scaling, it either increase or decrease EC2 instances, right? Then we can also create an alarm for EC2 actions. Let's say we want to stop or terminate, reboot, or recover an EC2 instance. Okay. Then also we have SMS service. This is mainly for sending notifications. Okay, so SMS service. So basically, we can send notifications. We can create an alarm for that. But okay, it's time to send your notifications. Also, we can choose the period on which to evaluate an alarm. Next, we can create a billing alarm on the CloudWatch billing metric. Okay, like let's say you have set up a billing threshold for any service, and you set an alarm that when this threshold is crossed, send me a alarm trigger, right? So in that case, you can create a billing alarm. So now we have alarm states. What are alarm states? We have okay, we have insufficient data, and we have alarm. These are the 3 states of CloudWatch alarm. So now what we will do is we will talk about alarms in the services. Okay, let's go to alarms. All alarms. We have here we have in alarm, we have all alarms, we have billing also. So if you go to billing, you will see that you can create an alarm over here for billing alerts. I won't do that. So it's very easy basically. CloudWatch can help you monitor the charges on your AWS bill by sending you email alerts. As I said, when charges exceed the threshold you define. So that's how you can create a billing alarm. Okay. Okay. Also, this is a very important point. You get 10 free alarms and 1,000 free email notifications each month as part of the AWS free year. Okay. So this is what CloudWatch alarms is about. Then we will talk about CloudWatch logs. CloudWatch logs. Okay. So CloudWatch logs can collect log from what are the services? Services collected log from. One is ECS, we'll talk about that. Oh, already we have talked about. So yeah, remember Elastic Container Service, the Dockers, where the Dockers are stored, the images are stored. So ECS, so collection from containers. Now we have Lambda. We already talked about Lambda. So collection from the function logs. Number 3, we have EC2 machines, right? Then we have route 53. We've not talked about it, but it's also a service which can log the DNS queries. Just for information. Okay, these are the services. Now, so let's see how the logs work on CloudWatch. Logs group we have. These are log groups we have. Now let's go to actions and see. So whatever logs we are getting, right? Whatever services we are using, let's say EC2, let's say Lambda, let's say AWS Glue, let's say EBS, ECS, whatever services we are using. Anytime we run a job, we'll see the logs are getting created. Where does it get stored? It gets stored in the CloudWatch. So we can create a group out of it. Let's say you have 10 AWS Glue jobs and the logs for that. So you can group them in one, say AWS Glue logs like that. Okay. This is how logs are used. Let's go to log insight. So the insight, same. It's the same as alarms when we worked on it. So you can just select your log groups, right? And then from the log groups, it will work on the logs individually and create a visualization on top of that. Okay, so this is basically about CloudWatch. And next we will talk about the Amazon Trusted Advisor in the next lecture. Thank you. Okay, so now we'll start talking about what is an auto scaling group. So see, let's take an example. In real life, the load on the websites and application can change, right? But in cloud, we can create and get rid of servers very quickly. Okay. So the thing is that an auto scaling group is basically to a group which automatically scales the applications or the resources as per the load on the system. Okay. So the goal. Number 1, scale out. Scale out means add EC2 instances, okay, to match an increased load. Number 2, scale in, remove EC2 instances to match the decreased need, right? Number 3, to ensure that we have a minimum and maximum number of machines running. Number 4, automatically register new instances to a load balancer, right? And number 5, we can replace the unhealthy instances. Okay, we'll talk about this. Now let's talk about the cost savings. We can run it only at an optimal capacity, okay, which is the principle of the cloud. Okay. Now, if we talk about the goals, so we understood that it's to scale out, that is add the EC2 instances. If there is an increased load, to scale in, that is remove the EC2 instances if, to match if there is a decreased load, to ensure that we have a minimum and maximum number of machines running, and automatically it registers new instances to a load balancer. So whenever there are new instances, you can automatically register to the load balancer. And also it can replace the unhealthy instances. We no need to keep it. We can replace it. Okay. Now we'll talk about how auto, let's see, right, ASG works with ELB. Okay. Okay. So I'll just draw a diagram on this. So let's say this is our traffic, web traffic. This is our load balancer. I'll just write LB. Okay. And then we have multiple EC2 instances. Okay. So as and when required, the load balancer, what it will do, it will balance its load to each of the EC2 instances. Now let's say there is an increased load. So we need to add another EC2 instance like this. So we'll add another EC2 instance. And now let's say we have an decreased load. So we will remove one EC2 instance like this. This is how the ASG works with the load balancer. Alright, so then, okay, there are some scaling strategies for ASG. Number 1 is manual scaling. What does it do? It updates the size of an ASG manually. Number 2 is dynamic scaling. What it does? It responds to changing demand. Okay. So there are 3 types in dynamic scaling. One is simple or step scaling. So what is then there is target tracking scaling. Then there is scheduled scaling. So let's say in target tracking scaling, we want a target. So let's say I want my average CPU, ASD CPU to be around 40%. So we will track the target with this kind of scaling. Now scheduled scaling. So let's say we want to increase the capacity at a particular time. Let's say 9 to 6 p.m. on Fridays. So we'll use scheduled scaling in that term. And simple or step scaling is basically, let's say it is on the requirement, it's on the changing demand. So let's say an alarm is triggered, okay, and when a threshold is reached, then what do? You add 2 units to it. So that is a simple and step scaling example. So yeah, I mean, this is pretty much about ASG and ELB and how it works on the cloud. So I'll just quickly show you on the console that how it is done. So remember we had created an EC2 instance. Over there only we'll have to see it. Okay, so we have here load balancers, load balancing, and auto scaling. So let's go to load balancers once. So basically you have to create a load balancer, the type you want. So whatever we have already learned about the type. Okay, so in terms of this is new gateway load balancer. We'll talk about that in details in the course. So whatever type you want to create, you can use that. So classic load balancer is previous generation. I said that it's getting obsolete, right? So let's say I want to have a application load balancer. So you want to give the load balancer name and all IP address and everything. And the region, see, we said that the load balancer should be at least available in 2 availability zones, right? So you have to use, select 2 availability zones in that case. Okay, and then we already learned about security groups, that what traffic we want to enable and disable. So all that you have to add and create the load balancer, right? And inside the EC2 instance, you can use this particular load balancer. Same for auto scaling groups also. So I'll just stop the recording and the share, and we'll start with the next lecture. Okay, so we'll talk about AWS Trusted Advisor. So what it does, as we get from the name, it's trusted and it advises, right? So basically it provides recommendations that helps us follow AWS best practices. Okay. Now, what it happens is the trusted advisor, let's call it TA. So TA evaluates the account by using some checks. So what are these checks? These checks identify how to optimize the AWS infrastructure. Okay. Also, how to improve security and performance, reduce the costs, and monitor service quotas. So, what are the types of support we have? We have talked about the basic support, developer support, business support, enterprise support, right? So the basic support and the developer support customers, they can access core security checks and checks for service quotas. Let's go to the hands-on part. We'll discuss more. Okay. So let's talk about cost optimization. Okay, I have to upgrade the support plan to get all the trusted advisor checks. Let's do one thing. Let's just note down the points. So the AWS basic support And the developer support, these customers can access core security checks and also checks for the service quotas. Now the business support and enterprise support customers, they can access all the checks, including cost optimization, security, fault tolerance, performance, and service quotas. So also TA, trusted advisor, it helps us to focus on the most important recommendations to optimize the cloud deployments, improve resilience, and address the security gaps. So what we'll do is we'll see AWS Trusted Advisor check reference. So this is the official Amazon AWS website. So see, you can view all the trusted advisor check names, descriptions, and IDs in the following reference. You can also sign with a trusted advisor, that's the console. So note, if you have a basic support and developer support plan, you can use the trusted advisor console to access all checks in the service limits category and following checks in the security category. So there are certain rules and regulations and restrictions to follow when it comes to the basic developer, enterprise, or business support plan, whichever your account is having. Okay, so based on that, the service AWS Trusted Advisor, it will recommend you on the basis of your plan that what will be beneficial for running your account. Okay. So mostly theoretical questions come from this part. Other than that, yeah, I mean, mostly theoretical questions. They'll give you a scenario and you have to find the answer for that. So we'll stop the. Okay. So as we know, ELB is elastic load balancer. So it's a kind of load balancer. Basically, it's a managed load balancer. So we had talked about managed, right? When we talked about managed, managed means the servers are hidden. We cannot see them. Okay. So what does it do? What is AWS point of view? So number one, AWS guarantees that it will be working. Okay. Also, AWS takes care of upgrades, maintenance, and the high availability. Number three is it costs less to set up your own load balancer, but for maintenance or upgrades, it takes effort. So let AWS do the work. Okay. So actually the topic is what is an elastic load balancer and why. Okay. So number 4. So if we only use a load balancer on our own, it will we can set it up on our own. But for maintenance, it will take effort. So let's place it on AWS and let's use the elastic load balancer. Okay. Now a very important point. There are 3 kinds of load balancers. It's a very important question. It comes in the exam as well, certification exam, like the kind of load balancer, and they give you scenarios to see which kind of load balancer will be appropriate for that particular scenario. So 3 kinds of load balancers offered by AWS. Okay. Now, number 1, application load balancer. Number 2, network load balancer. Number 3, classic load balancer. Okay. So application load balancer, it's basically we see it's related to web application. So all the HTTP requests or the HTTPS requests, they will go to this application layer and an application load balancer. Now network load balancer. It basically allows for TCP traffic. We remember we learned about TCP, SSH, the ports, right? So here comes the load balancers function. So it allows for TCP. Also, it has ultra high performance. So wherever you need to, sorry, performance, wherever you need to put, load your network, load the balance across your network, use network load balancer, NLP. And then comes classic load balance. Okay, this is not in use that much. It's becoming obsolete. But it's good to know about classic load balancer. So mainly nowadays, only application load balancer, network load balancer, these 2 are used. Okay. Okay. Now, next we will talk about, so about load balance, elastic load balancer, we mainly have the theory part. We'll do a bit of hands-on at the end once we complete the auto scaling group, which is ASG also. So what is an auto scaling group? Okay, let's talk about this in the next lecture. Okay, so now let's talk about load balancing. So we already talked what is load. So how to balance that? That is load balancing. So load, we have a term called load balancers. So load balancers are basically servers that forward the internet traffic to multiple servers, basically distributing the load from one computer to multiple computers, right? So servers, multiple servers, and as in the EC2 instances downstream. Okay. Now let's just quickly draw a diagram about it. So let's say we have 3 users. Let's say we have 3 users. Okay, we have a load balancer over here, and these are the multiple servers. It is balancing the load inflow. So what happens is that this is user 1, this is user 2, this is user 3. This is the load balancer, and these are the EC2 instances. EC2, EC2, EC2. Okay, so what happens is, suppose user 1 is sending the traffic to and fro. User 1 to load balancer to user 1. Now, so user 1 is sending. So user 1 is sending this load balancer. So what the load balancer does, it forwards this traffic to this instance, this EC2 instance. Now what happens? This EC2 instance in turn, after load balancing it, it turns to the load balancer, and load balancer turns the traffic to the user 1. Right? It's a to and fro system. Same for user 2 to this EC2 machine, user 3 to this EC2 machine. Okay? So this is how the load balancer works. Now we want to know about why use a load balancer. Okay, number 1 point which I can think of is spread the load or divide the load across multiple downstream instances. Okay. Number 2, seamlessly handle failures of downstream instances. So since the load is balanced, even if the downstream instances fail, we can seamlessly handle that. Now, for doing regular health checks to our instances. Also, this is directly linked to high availability across the multiple AZ. I think this is pretty much clear from the points itself. Okay. So now we will talk about ELB, which is Elastic Load Balancer. Okay, let's start talking about this in the next lecture. Okay, so let's talk about high availability. So high availability normally goes in hand with horizontal scaling. Okay, so what does high availability mean? It means running the system in at least 2 availability zones. We have talked about availability zones. So if your system is running at least 2 availability zones, that means it's highly available, and that means the disaster recovery is also higher. So the goal of high availability is basically to survive a data center loss. Data centers are where the resources are stored. So basically to survive a disaster. Okay, great. So now we'll talk about the examples of high availability and scalability for EC2. Okay, so let's talk about vertical scaling. So we've already talked vertical scaling is increase of instance size. That means scale up or down. Okay. So let's say from T2 micro, we're talking about EC2 instance, T2 micro to T2 large. This is scale up, and scale down will be T2 large to T2 micro, like that. So changing the instance size up, down. Yeah. All right. So now, okay, we'll talk about horizontal scaling. So we already talked about it. It's increase in the number of instances. That means scale out or scale in. Increase the number of instances. Okay. So what are the types? We have auto scaling group and we have load balancer. Now we understand where this topic come from. Auto scaling group and load balancer. Okay. So similarly, high availability example. Okay, what is the meaning of high availability? Run the same instances within multiple availability zones, right? So the examples we have are auto scaling group, multi-AZ, and load balancer, multi-AZ. This is in terms of the EC2 instances. Okay. Now we will talk about scalability versus elasticity versus agility. Okay, let's talk about this in the next session, next lecture. Accommodate a larger load by making the hardware stronger, that is scale up, or by adding nodes, systems, which is also known as scale out. So we are talking about both vertical scalability and horizontal scalability over here. Now let's see about elasticity. So once a system is scalable, what is the meaning of elasticity? Normally also it means stretching, right? So that means that once the system is scalable, elasticity means that there will be some auto scaling happening. Okay, so auto scaling, why? So that the system can stretch basically elasticity based on the load. So what does it mean? That once the system, you made the system scalable, so elasticity means that automatically some scaling will be happening. Either scale up, the increasing the instance size, or scale out, adding nodes or increasing the number of systems. So that this auto scaling is because so that this based on the load, whatever load it is, the system can stretch itself, right? So what are the advantages? It's pay per use. Okay. Also, it optimize the costs. Why? Because it's as per the requirement, right? So this is what elasticity is about. Now we will talk about agility. So basically agility is that you can reduce the time to make the resources available to the developers from weeks to just minutes. So it may be talk about agile system, right? So agile system, it's basically previously if you wanted to make the system available to the developers, it would take weeks to do that. But we can in agility, in agile model, we can reduce the time to make it available in just a few minutes time. Okay. So this is the difference. Now next, we will talk about load balancing. Now I guess you know what load is. Load is basically the load that is induced on the system, right? So suppose let's just take a very small example, like you have a computer of some specific memory, and you start loading more files into it. It exceeds it. So that is load. So similarly, it happens in the EC2 instances as well in AWS, and how we can balance that. So we'll discuss this in the next lecture. Okay, so now today we are going to talk about ESG and ELB. So ESG is basically auto scaling group, and ELB is elastic load balancer. So what is a auto scaling group? Before that, we need to understand what is the meaning of scalability and high availability. So scalability means, we had discussed in the beginning also, scalability means that an application or a system can handle greater loads just by adapting. What does it mean? That a system system can handle greater loads by adapting. So basically, it is not confined to just one system or a fixed number of resources. You can always upscale the number of resources and it can handle it just by adapting of the scalability. So there are two kinds. One is vertical, second one is horizontal, which is also known as elasticity. Okay, so scalability is somehow related to high availability, but it's different. It's a bit different. We'll come to know about that. So now let's talk about vertical scalability. So it basically means scalability, vertical scalability means, since we are talking about, let's say, the EC2 instances. So if we want to vertically scalable an EC2 instance, it basically means increasing the size of the EC2 instance. So for example, let's take an example. We have an application running on, we had talked about the sizes, right? T2 micro, and I wanted to run on T2 large. Okay. So if I want to do that, what I can do vertical scalability in this case. Okay. Now it's basic, it's mostly common in non-distributed systems like database. Okay. Now there's one important point. Note, there's usually a limit to how much you can vertically scale. There's a hardware limit to it. Okay, we'll talk about that. Now, let's talk about horizontal scalability. So it means, so when we were talking about vertical scalability, it meant increasing the size. Horizontal scalability means increasing the number of instances or systems. Okay. So now, since we are talking about increasing the number of instances, it's common for distributed systems. That means database. It is also very common for web applications or modern applications. Now, horizontal scalability does not have any limit as such, and it's easy also. So what's the difference between horizontal scalability and vertical scalability? Vertical scalability, we can use the increase the size of the instances or the system. In horizontal scalability, will just increase the number of instances or systems. Okay. Now talking about high availability. Okay, let's talk about it in the next lecture.